Hello. So today we will start a topic or discuss a topic known as waterworks engineering. Okay. So waterworks engineering. First, we will talk about the purpose or of waterworks engineering or the benefits, or you can say why we are using this waterworks engineering technique. The first one is water engineers ensure the safe delivery of water for irrigation and human consumption, as well as the effective removal or recycling of wastewater. Water engineers have many responsibilities, both technical and non-technical. They ensure that citizens are provided with a continuous supply of clean, contaminated water for drinking, living, and recreational purposes. Water engineers not only design water management systems but often oversee the construction and maintenance of the systems as well. So, from these 3 points, we can say that water engineers basically look after the wastewater treatment procedure. That means wastewater should not be given to the human beings for their use and drinking purpose. Okay, for irrigation as well as for human consumption and other works that human beings do. For that, they should supply a clean water, fresh, clean water. Okay, that should be uncontaminated. That should not be contaminated. That should be uncontaminated. Okay, for this line, like uncontaminated water for drinking, living, and recreational purposes. For the human society, the water provided should be uncontaminated. Okay, and for the supply of fresh water or the water that is good for use for the human beings, systems are being built, right? So those water engineers take care of the systems and maintain them so that good water or fresh water is being available for the human beings. They demonstrate a genuine knowledge and interest of the water industry and environmental issues, designing sewer improvement plans or flood defense programs, global warming, aging infrastructure, population growth, and higher quality living standards. Some of the challenges a water engineer need to address. So, a water engineer keeps in his mind the environmental issues, that is, the problems that can be caused due to wastewater, like the soil pollution, water pollution, which is harmful for the human beings, right? So they keep in mind. Okay. Next subtopic is water demand. Water demand is basically in easy language, I can say it is the amount of water which is required by the human population in 365 days. Every day, the water that is being required for the human population. In scientific terms, we have like brought this big definition into a smaller one. What is it? It is the ratio of the annual average water consumption of a community to the population for 365 days. So per capita demand is the annual average amount of daily water required for one person. So the amount of water which is required by one person for 365 days, that is only water demand. Okay. Next comes your population forecasting. What is population forecasting? To know how much water is required for the population, we should know how much is the population. So how will you determine how much is the population? These are the methods by which you can determine. Population forecasting is defined as a method of determining the expected population for a particular design period of a water supply system with the help of study and analysis of future events and available records. That means determining the population, expected population in an area. What are the methods? First method is arithmetic increase method. Where we can apply this method? Where to areas where it is found that the rate of increase of population with time is constant. That means time is increasing, but the rate of increase is constant. The equation is given by dp by dt is equals to constant. Okay. This is the equation where Pn is equal to population of an area, Po is last known population, and A is equals to number of decades. Next is geometric progression method. This method is for the condition where dp by dt is equal to kgp. You just know these methods, you don't require this right now. Okay, for this particular presentation, you just know what are the methods. Details I will come up with later. This is geometric increase method or Euler-Bankasi method. This is employed in an area where the population is rapidly increasing. That means don't keep in mind the time, they are rapidly increasing. Okay. Fourth comes decreasing rate of growth method. This is applied to a city that owns a limiting saturation population. That means after a certain period of time, it will be saturated. It will be filled up. Okay. Next, very important part, that is stages of waterworks engineering. What are the stages? First stage is collection of raw water from sources. Second, treatment of raw water. Third, distribution of treated water. Fourth, treatment of wastewater. So first one, source of raw water. We all know raw water comes from rainfall or groundwater or well, lakes and rivers. So from here, the raw water is collected. That can be contaminated as well as uncontaminated. Okay. Now we will treat the raw water. So this is the raw water system. What are they? The exact components of the raw water system depend on the quality of water being drawn from in relation to the quality of water being needed. What is the thing? I have told you that raw water can be contaminated as well as non-contaminated. So after I draw raw water, I have to check how much is the contamination. If the contamination is very high, then I need to treat it very well. If the contamination is very minimum, then a small amount of treatment will go. So I have to keep in mind that what is the quality of water that I have drawn to the quality of water that I need, right? Chemical feed to help facilitate the flocculation or coagulation of any suspended solids. Since that there are certain chemical treatments which happens. Clarify to settle down the larger solids, filtration and control panel. So these are the ways through which we can treat a raw water. This is the diagram. See, it is going raw water, then it is coming to coagulation, flocculation, sedimentation, disinfection, and finally it is distributed for the home consumption. Now comes your wastewater treatment system. Wastewater. Supposedly the water is a wastewater. How? Then what happens? This is the diagram. Okay. There are three major methods through which we can treat a wastewater. What are they? First is primary, secondary, tertiary. Primary involves sedimentation. Okay. Secondary involves soluble organic matter solid that escape primary treatment. And tertiary is known as polishing, disinfects water to the highest standard. So primary means very basic methods which are being involved. Secondary is what happens in secondary treatment. Those who escape the primary, those who cannot be treated with the help of primary treatment, they are being treated by secondary treatment. And lastly is tertiary, which is to a higher standards. Next, the water is being distributed to the households. And distribution has two methods. One is continuous, another is intermittent system. Continuous system is what? It is a system where the water is supplied to the community during 24 hours of the day. You can get the water supply 24 hours. Okay. And intermittent is, it is for a particular fixed time in a day or alternate days. Remember, okay, continuous means for 24 hours, intermittent means for a fixed time period of a day or alternate days. So this is the conclusion. I have given here the aims of the water supply, which we have already understood. That is, main aim is that it should treat the wastewater. The wastewater should be treated before available for the human use. Similarly, for industrial purpose also it should be treated before it is discharged because it causes environmental issues. That was for today. I'll come up with more topics. Thank you.